नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे यूट्यूब चैनल केमिस्ट्री एकेडमी फॉर आईटी जेई एंड नीट. This is our problem series for JEE Advanced. We are going to discuss the theory through problems. Hope this will be useful for all of you. I will request you to like and subscribe our channel. Section 1, one or more option correct type questions. This section contains 10 multiple choice questions. Each question has 4 choice A, B, C, D, out of which one or more are correct. This is the marking scheme: +4 -1. Select the correct statements. Schottky defect is shown by CSCl. Frankel defect is shown by ZNS. On heating, ZNO turns yellow. On increasing pressure, coordination number of CSCl decreases to that of NaCl. So let us discuss this problem one by one. We are starting with first statement, A statement. Schottky defect is shown by CSCl. When we are discussing about Schottky defect, you can see this picture. This picture is from NCRT and it is showing Schottky defect. So in Schottky defect, equal number of cation and anion is missing from their lattice side. Suppose here this is anion, cation, anion, then this is a position of cation which is missing. Same way you can see here that there is another site where the anion is missing, and same way we can find out that this is anion is missing, then this is cation is missing, right? So here if it is NaCl type, +1 -1, if it is NaCl type of crystal, we can say that equal number of cation and anion is missing, then it is known as Schottky defect. So in Schottky defect, since cation and anion both are missing, means both have equal ease to move outside the crystal, and that will be possible when the difference in the size of cation and anion will be very small. And when the size difference between cation and anion is small, it means that radius ratio, radius of cation upon radius of anion, is nearer to 1. So it means that higher value of radius ratio means higher coordination number. So Schottky defect is observed in those crystals having higher coordination number. We know that CSCl is a crystal which is simple cubic with respect to anion, and cation is present in the cubic void. At the center of the cube, cesium plus is there, and at the corner, Cl minus ion is there. So the cation and anion both have a coordination number of 8, and in ionic crystal, coordination number 8 is the highest coordination number we are getting, right? So this statement seems to be correct. So A statement seems to be correct. Now moving to B option, let us discuss the B option. Frankel defect is shown by ZNS. When what we know about ZNS having two type of crystalline structure. One crystalline structure is known as zinc blend, which is very common. So when we are talking about this zinc blend, it is FCC with respect to anion, and cation is present in tetrahedral void, and half of the tetrahedral voids are occupied. It has a diamond type of a structure. So the coordination number of cation is equal to 4. Coordination number 4 will be a lower coordination number. Mainly when we are discussing about ionic solid, 3 types of coordination number is very common. That is 4, 6 and 8. So we can put 4 in low coordination number. We put 8 in higher coordination number, and 6 is intermediate. Some part of 6 will come in higher and some part of 6 will come in lower. So zinc blend has a cation whose coordination number is 4. So when we are discussing about Frankel defect, there is no change in density, right? Some of the ions will leave their sites, some of the cation will leave their sites and go into the interstitial position. So only the smaller ions can move easily. So here if the cation is small, these type of defects will be observed. So if the cation is small with respect to anion, only cation can move more easily. So this type of defect is observed in those crystals having low coordination number. This when we are talking about ZNS, there are two types of ZNS. One is zinc blende and other is woodsite. So when we are discussing about woodsite, we are saying that it is HCP with respect to anion, and cation is present in tetrahedral void. So again, from here I can say that since cation is present in tetrahedral void, the coordination number of cation is equal to 4. So either I take wurtzite or I take zinc blend, the coordination number of cation in ZNS is low coordination number. If it is low coordination number, then Frankel defect is observed. So this statement also seems to be correct. A option is correct as well as B option is also correct. Let us move to the C option. On C option, they are saying that on heating, zinc oxide turns yellow. So this is the structure we have taken from JD Lee. So in zinc oxide, when we are heating, right? On heating, what will happen that zinc oxide will break down to form Zn2 plus ion plus half of O2 gas plus 2 electrons. So what will happen that on heating this some like in solid, some of the oxide ion will leave this crystal and go outside in the form of oxygen gas, and the Zn2 plus ions will enter into this crystal. And this oxygen, when we are this oxygen, when it is moving outside, it will leave some electrons, right? So here if I'm talking about zinc oxide, this A is Zn2 plus and B is oxide ion, and then same type of phenomena is happening, right? So the on heating effect, what will happen, Zn zinc oxide is colorless, but on heating it becomes yellow because these electrons are now, when the light will incident, they will get excited, and when they will get de-excited, they will emit energy, and if it is in visible color, we can see the color, right? So the type of the color is because of these electrons, right? Excitation and de-excitation of the electrons in interstitial sites. And if I apply potential difference on this electron can move more easily with respect to this cation. So conductivity is because of electrons. So most important point regarding this, that this type of defected solid has N type of semiconduction. N type semiconduction is observed because you can see here that when oxide ion will go, the defected solid has more number of zinc atoms. So I can write 1 plus delta O, right? Now the number of zinc ions is more than that of, so it is we can say that it is metal excess defect. In case of metal excess defect, there is N type of semiconduction. So this part is important here. So on heating, zinc oxide turns yellow. This is a correct statement, and explanation is the electrons present in interstitial positions when they are getting excited, when light will incident, and then when they will de-excite, they will emit energy which is in visible range and it has yellow color. D option, on increasing pressure, coordination number of CSCl decreases to that of NaCl. When we are discussing about this D option, it's a very common sense that if we apply pressure, right? Suppose this is a substance and we are increasing pressure over this substance. So what will happen on an increasing pressure? The ions or the particles of the substance will come nearer to each other. When they will come nearer to each other, then coordination number is going to increase. So this statement is given in NCERT also, that when we are applying pressure, the coordination number will increase, and when we are heating, expansion will take place, so coordination number will decrease. These 2 points are important, right? So here when we are saying that on applying pressure, coordination number should increase, right? So if I'm saying that I have NaCl type of crystal where the coordination number of cation and coordination number of anion is equal to 6, coordination number of both cation and anion is equal to 6. When in case of CSCl, I can say that the coordination number of cation and anion is equal to 8. So on increasing pressure, a low coordination substance should convert into high coordination substance. Here, D statement will be incorrect because they are saying that CSCl decreases to NaCl. That will happen when we heat the substance. On heating, particles will go away from each other where the coordination number is going to decrease. So answer of this question should be A, B, and C. They are asking about the correct answers. So answers will be A, B, and C. Moving to question number 2. Element X crystallizes in a 12 coordination FCC lattice. On applying high temperature, it changes to coordination number 8. We have discussed that if we are applying pressure, coordination number will increase. If we heat the substance, particles will go away, coordination number will decrease. So here on heating the substance, the coordination number will decrease from 12 to 8. Since it is element, it is metallic crystal. So in metallic crystal, highest coordination number we find is 12. Now it is converted into coordination number 8, that is BCC. So FCC is converted into BCC lattice. Find the ratio of density of the crystal lattice before and after applying high temperature. Okay, so we have to calculate what is the ratio. So in order to calculate the ratio, if the same element is there and it is existing in two crystalline structures, so we are assuming that the radius of that atom is same in both the crystals. So here when we are saying that it is FCC, I can write that what is the relation for edge length of FCC cube and the relation between radius of the element, right? So A is equal to 2 root 2 R, where R is radius of atom. It is the condition for FCC. In case of BCC, we know that the atoms present along the body diagonal are touching each other. So based on that, I can say that under root 3 times of edge length of BCC, that is body diagonal of the cube, should be 4 times of radius of atom. So from here I can calculate that what is the edge length of BCC unit cell, that is equal to 4 by under root 3 times of radius of atom. And now we can compare the density of the crystal before and after, means density of FCC upon density of BCC. Density is mass upon volume, mass of unit cell upon volume of unit cell. So for FCC mass, in FCC there are 4 atoms. So mass of one atom is equal to atomic mass divided by Avogadro number. So if atomic mass is in gram, this is coming in gram, divided by edge length of FCC whole cube. When we are discussing about BCC, there are 2 atoms per unit cell. So the mass of one atom is equal to atomic mass in gram divided by Avogadro number. So on simplification, we can say that here divided by volume of BCC unit cell. So it will come in numerator, edge length of BCC whole cube. So now if I simplify this 2 and this portion will cancel out. Here we are getting 2. So I can write that 2 into edge length of BCC, I can write that is equal to 4 by root 3 radius of atom whole cube upon edge length of FCC whole cube. Edge length of FCC is equal to 2 root 2 R radius of atom whole cube. So now if I simplify this, the radius of atom in numerator and denominator will cancel out. This I can write that this is equal to 2 into 64 divided by 3 root 3. And on simplification of this, I can write this is 16 root 2. So if I further simplify, this will be 4 times. So that is equal to 8 3 root 3 into root 2. Or you can further simplify, this is 4 root 2 upon 3 root 3, right? So in this way we can say that this ratio should be 2 times of root 2 whole cube upon root 3 whole cube, right? So from here we are getting that the answer is D.